Greetings and welcome, friends. We've been talking about trigonometric functions on the unit circle, and our homework last night was on page 296. And here's question 21 that we're looking at. It says if cosine of theta is 0, all right, so cosine of some angle is 0, what is secant theta? All right, so let's take a look at this. Now, we might recall that secant theta is the reciprocal of cosine, right? So if cosine theta is 0, we could actually view that as being like 0 over 1. And then secant theta being the reciprocal of that would be 1 over 0, which you can never divide by that, but by 0, so that would be undefined. And just as kind of a concept, where is cosine equal to 0? We talked that cosine is the same as the y-coordinate, right? No, cosine was x, sorry. Cosine theta is equal to x. So where are my x-coordinates 0? Anytime I'm on the y-axis, right? So here would be like 0, 1 or 0, -1. And for what angles does that occur for? That would be like 90 degrees or 270 degrees. Or any coterminal angle with those, in fact. Actually, those are 180 degrees apart. I guess you could end up saying, and this is a skill that we'll gain later, that you could say cosine theta equals 0. This is way beyond what this question was actually asking. For all theta equal to 90 degrees plus 180 k. Where if I add 180 to that, or another 180, or another 180, or subtract 180s, where k is an integer. So basically, that's where cosine is 0 for all of these coterminal angles. And I was able to actually do 180 because they happen to be 180 degrees apart. But anyways.
You want to go x coordinate and is on the y-axis line.
Yep. Yeah. I was just kind of taking opportunity to expand this question, but really all you had to do was write this orange part and you would have been fine. But that's the idea. Now let's see, for sine and cosine, those functions are not ever undefined for any angle. Tangent is undefined. I believe it was at 90 degrees, specifically because tangent we found out was equal to sine over cosine, and if cosine is equal to 0, it turns out tangent's actually going to be undefined at these same locations. And the reciprocal functions all have some locations of undefined tacity, if that's the way I'd describe it, because sine can equal 0 at 0 degrees and 180 degrees in all of their coterminal angles. So cosecant, being the reciprocal of 0, 1 over 0 or whatever, would also be undefined at those locations. And cotangent, I believe, also has some... Actually, wait, now I have to think about it. I don't know. Well, anyways, we'll come back to those far, far later down the road. It'll be fine. It'll be fine. So let's see. Here it goes. This is the big question. This is the core concept of this section. Use the unit circle to find the 6 values, or the values of the 6 trigonometric functions for each angle. So here we've got a 210-degree angle. So let me draw a picture of this. So here's 180. 210 is 30 degrees more than that. So it's less than 45 degrees more than that. So my reference angle, I actually can see is going to be 30 degrees. If I wanted to calculate that for real, I could actually say alpha is equal to 210 minus 180, which is 30. So there's my reference angle. Now, we'll also end up having to figure out the signage or polarity of our trig functions in quadrant 3. So if I want sine of 210, cosine 210, And technically I need to have degrees there, even though it's a pain to write that all the time. And tan of 210, I'm going to start with these. Sine of 210 that's going to be the same as sine of 30. However, in quadrant 3, the y value is negative, so that's the same as negative sine of 30, right? And negative sine of 30, if you do the hand trick, that's going to be negative 1/2. Or if you just have sine of 30 memorized, that would work. So cosine of 210, well, in quadrant 3, cosine is also negative, so that's negative cosine of 30. And cosine of 30 is root 3 over 2, but we've got that minus sign in front, so negative root 3 over 2. Right? So there were 3 fingers to the right of my down finger, square root that, divide by 2 is how I'm figuring that out. Now, tangent of this, tangent is going to be positive in this quadrant because it's the ratio of sine to cosine, so negative divided by negative is positive. So this will be the same as tangent of 30. Positive tan 30, and I would put down my 30-degree finger and do the square root of the fingers to the left divided by the square root of the fingers to the right. That's just going to be 1 over the square root of 3, I believe, right? Or square root of 1 over the square root of 3. And that's the same as the square root of 3 over 3. Now, all of their reciprocal functions, if I reciprocate a negative number, it stays negative. If I reciprocate a positive number, it stays positive. So all of their reciprocal functions have the same signage. So let's actually figure out cosecant 210 degrees is going to be negative. Actually, if I was just asked straight up to find out what the cosecant of 210 was, I would actually write that as negative 1 over sine of 30. So it's the reciprocal of the sine function is kind of how I'd think about that. And then once I find sine, I could flip it. And that the reciprocal of negative 1/2 is just going to be negative 2. And it's still going to be negative because it has the same sign as sine. What was your question? Sorry.
Negative, and then the sign.
Well, if I wrote sine of 210, then I wouldn't have had that minus sign. But sine of 30 itself, this part is positive. It's that minus sign out front that was making it negative. So yeah, so I was just taking into account the sign of this in advance. Let's see, secant of 210 would equal the negative 1 over the cosine of 30, because it's the reciprocal of the cosine. Its reference angle is 30. It's negative because it's in that quadrant. And that's going to be negative 2 over square root of 3, which is negative 2 roots of 3 over 3 when I rationalize the denominator, getting rid of that radical. And lastly, cotangent of 210. It's going to be positive just like its tangent buddy was. That's going to be the same as 1 over tan of 30. So that's going to be, if I reciprocate 1 over the square root of 3, that's just going to be the square root of 3 over 1, or just the square root of 3.
So you're not subtracting 30 from 210, right? You're just finding, you're just finding the 30-degree numbers, I guess.
Yep. So when I do sine of 30, I literally put down my 30-degree finger and calculate the number of fingers to the left of it. So yeah, this sign only affects the outcome of the ratio. It's not like I'm saying negative 30 degrees, which is different than negative sine of 30, because that would be in a different quadrant.
How did you get the negative sine of 30 and the cosine of 30?
Because well, the sine of a 210 is the same as the sine of its reference angle, so it's all about the reference angle. And then the positive or negative was all just based on what quadrant it is and for that function. So you end up having to memorize those charts, unfortunately. Or you can just think about sine is always the y coordinate, cosine's the x coordinate, and in this quadrant, my coordinates are negative, negative, right? Negative x coordinates and negative y coordinates. So a bunch of different connections to make. There's a lot going on, I know. So let's see. So for instance, here's question 29, just straight up asking me what's the cosecant of 390. The first thing I might do is actually try to figure out a coterminal angle with 390 that is 300, less than 360 but still positive. So I'd subtract 360 and I'd get, that looks like 30 degrees, is that right? and the reference angle of a 30-degree angle is still 30 degrees. So I could say alpha equals 30 as well in this case. All right, so just to draw a picture, it's always a good idea to do that. Give us a better understanding of this. So my original 390-degree angle looked like this, right? I found a coterminal angle, which is in the first quadrant, your angles are the same as your reference angles. So here's the 30 degrees. And we're in quadrant 1, cosecant being the reciprocal of sine. Well, actually, sine, cosine, cosecant, and secant are all positive in this quadrant. So this is going to be positive as well. So if I want to calculate this, I could say that cosecant of 390 is equal to the reciprocal of sine of 30. Sine of 30 is a half, and if I reciprocate 1/2, I get 2. Right, so it's definitely a little bit tricky, lots of moving parts with this, but you just kind of have to connect all of those different little concepts, pull them together. And I think drawing a picture is always helpful, right? If you didn't memorize what quadrants your things were positive in, just think about the fact that, you know, cosine is x, sine is y, all sorts of good stuff. Let's see, last concept here. So this time I'm going to plot a point. So negative 6, 6 is right up here. All right. And how far away, well, actually, maybe that's not the right question to ask just yet. But if I want to think about the angle that's in standard position, how do they say it? So find the 6 trig functions for an angle theta in standard position if a point with the given coordinate lies on the terminal side. So if this is on the terminal side of my angle looks something like this. Now, looking at this, I actually can figure out theta right away. I don't know if you guys can. Maybe that's not as obvious. But, well, let's actually draw this triangle. Let's draw our triangle and see if... Yeah, it's going to be 45 for the reference angle. So if I draw my triangle, this dimension is negative 6. This dimension is positive 6. The hypotenuse is actually going to be 6 square roots of 2. Although we could actually find that out using our little r formula that we had earlier. The radius, if I was thinking about this as a circle, right, is equal to the square root of x squared plus y squared, was the little formula we got at the end of class. So r is equal to the square root of negative 6 squared plus 6 squared. So that's the square root of 36 plus 36, which actually I could just break. That's going to be the square root of 72, or I could just think of that as 2 36s. And the square root of 36 is 6 roots of 2. Or, technically in this case, I realized this was going to be a special right triangle. I could have just said that the hypotenuse is the square root of 2 times longer than either of the legs. All right. And now once you've realized this, hopefully you could immediately realize that this is 45 degrees because of the special nature of this triangle. This actually also happens to be 45 in that case. So, question, what would my original angle have been if the reference angle was 45 and it was in quadrant 2? What's this yellow angle? Yeah, 90 plus 45, or 135 degrees. All right. I also could have figured that out by doing 180 minus 45 would give me the remaining angle there, using angle addition postulate. So, all of that work, I figured out all of this stuff, and now I'm just going to figure out the 6 trig ratios, all regarding these values. So this is my x, this is my y, and this is my r. All right, and we can actually calculate these rather quickly, or just using opposite over adjacent, all that stuff. So sine of 135 degrees is going to equal, well, from this angle's perspective, right? Sine is opposite over hypotenuse, so 6 over 6 square roots of 2. And actually, I don't even have to worry about the signage because this already had the negative there. that's going to equal 1 over the square root of 2, or root 2 over 2. Right. Cosine of 135. Actually, I could, if you wanted, you could even rewrite these in terms of the reference angles first, but you don't have to. Would be adjacent over hypotenuse, so that's negative 6 over 6 square root of 2. So that's, the 6's cancel out, that's negative 1 over the square root of 2, or negative rad 2 over 2. And tan 135 would be opposite over adjacent, so that's 6 over negative 6, or negative 1. And notice that the signs of all of these happen to work out properly. Sine is positive in the quadrant 2, cosine's negative, and tangent's negative because sine and cosine have different signs. All right, let's figure out, I might have enough room over here. Let's do this for cosecant of 135. That's just the reciprocal of this, or the reciprocal of that. It's just going to be the square root of 2. For secant 135, the reciprocal of this is going to be negative rad 2. And cotan 135, well, the reciprocal of negative 1 is still negative 1. All right. So a lot of this just stemmed from being able to draw the triangle. I actually don't even care if you have this formula memorized. It will be more important later on in pre-calculus. But right now, if you draw that triangle, you guys could have just straight up Pythagorean theoremed that, or special right triangled it in that case. So it's not that bad. But that's the idea is, right, you could calculate all of these based off of this stuff. I do want to point out that the ratios still reduce, notice, to the original ratio, even though our radius was longer than the unit circle radius would have been. But the ratios are always the same because these triangles are all similar as long as they have the same angles, which is kind of the big idea behind using these trig ratios. So thanks for watching, Internet friends. Bye-bye.